Hello everyone. Now we are going to see a new topic that is called design, software design. And in this, we are going to learn about various design concepts and principles. And actually, we are going to see what are the different software design approaches and various patterns, styles, and finally, we will see what is an interface design. Let's begin with software design principles. But before studying the principles, let us correlate or reconcile the requirement analysis model and the basic design concepts, right? The components of the design models are the data design, the architectural design, the interface design, and the procedural design. The data design actually transforms information domain model into data structures required to implement the software. Likewise, you are having lots of domains, right? Like a mechanical domain, maybe they are financial domain, maybe they are medical domain, maybe they are. So you are having a lots of models like domains, and you have various data structures available to store the data, to process the data, and to transform the data. Now you want to pick and choose the right data structures based on the domain that you are going to work with. So that is known as data design. The next thing is called architectural design. The architectural design defines the relationship among the major structural elements of the software. Now, how the major structural elements that we generally call as modules or packages or components, and these components, how they talk to each other is being defined or is being shown up in the architectural design of a particular module. Like if you're sitting in a room, you might have a wall, you might have a ceiling, you might have a floor, right? So a wall is a different component, ceiling is a different component, and floor is a different component. How they are related to each other defines the structure of the room, right? So this is the called architecture of the room. You have a multiple architectures. You cannot call a bungalow a duplex, and you cannot call a duplex a flat because they are different architecturally, right? That's why what we mean when you change the architecture, the system changes now, right? Now, the next thing is called interface design. It describes how the software components how it communicates with systems that interact it with it and with the humans. So now this component or this software that you are creating has to interface with different machines as well as different type of human beings. So how this interface should handle different type of interactions or activities are a part of interface designs. And you also have something called as procedural design that transforms structural elements of the architecture into a procedural description of the software components. Because when you create procedures, then only you can create much detailed software. So we are not going to touch about procedural design. We will limit ourselves studying about the data design concepts, and then the architectural design and the interface design. So let's see one relationship between these models and the analysis model requirement analysis models that we actually studied in our previous classes. The analysis model on the left side and the design model right side are related to each other. On the analysis model, we have seen data flow diagram or state diagrams or process specifications or controller specifications, and all those things that we studied in the requirement analysis model are giving input to the design model, as you can see from this diagram. A different state is a pyramid shown, a design pyramid that is shown up here. The bottom of the pyramid is a data design. As you move up, you are actually going to create more valuable design concepts. So each and everything is going to be a part of the data design model which you have actually studied in your past, right? Now coming to the various concepts that actually design should adhere to. The first is called an abstraction. Abstraction permits one to concentrate on a problem at some level of the abstraction without regards to the lower details. At the highest level of abstraction, a solution is stated in the broad terms using the language of the problem environment. At the lower level, a procedural orientation is taken, and the lowest level of the abstraction, the solution is stated in a manner that can be directly implemented. So, if you go and read these lines, if you pause it out and read them, you will understand. But let me give you an example right now. Let's suppose you want to teach a vehicle or a car to someone, right? You only need to tell him or her that this is the steering of the car, these are the gears, and these are the various accelerator, clutch, and brake, the ABC part. So if that person knows these five components, he know how to control it. Okay, it's his inner strength, right? Mental strength. So if he knows all these five components that are part of the great vehicle, he or she can control the car. He or she does not need to know how this when you press a clutch and you pull the gear, how these gears are changing, right? When you push a brake, how this frictionally, how your vehicle stops within seconds. So the mechanical part of how the car is operating is you should not be knowing. So what you need to know as a customer is the superficial part. Okay, now before going to buy a car, when you went to the company or we went to an outlet, what you say out that you are looking for a car that may be sufficient for four people sitting in your family. Okay, you need to have something, you state it out in pure words. Okay, you don't point it out to car, might be possible you don't know which car is best suits for your company, for your family. So what you do, you actually state it out in words. The stating out his word is the highest level of abstraction that is written in the second point is stated in the broad term using the language of the problem environment that you want to talk to, right? Likewise, you take out your phone, you want to search a video on a YouTube. What you do, you may type in out, but sometimes you actually don't remember how the wordings, also you don't remember the exact topic or the caption of the video, right? So what you do, you state it out in terms of a language, right? So this is the broadest, the highest level of abstractions that is given to a machine or a human being. Based on your level of abstraction, what you do, that person is going at a lower level of abstraction as the procedural orientation is taken. That means he process it out your query, and finally this is you go to but he is you are not going to a level of the next level. He is actually processing it and going it to the lower level, and finally the final procedure is where your particular solution is actually going to be implemented, right? So one way of doing this is this understanding is with the help of examples. Second thing is you have actually seen DFD in our previous classes. What is a DFD? It is a data flow diagram, and actually it has multiple levels. The easiest level was the level 0 or the context level DFD, which actually has one process and some set of inputs, some set of outputs. So that particular DFD is supposed to be as the highest level of abstraction. In the next level, what you do, you don't change the input and output. What you do, you expand the process within that particular stage 1 or the level 0, right? So now you're going to the lower level of abstraction. And finally, in the level 1 of level 2 of the DFD, what you're going to do, you are going to expand the sub processes of the greater process. Now you're going to the lowest level of abstraction. With one by one step, you're going from the easiest way to the hardest way. You are now when like it is with the help of Google Maps. You open a Google Map, it will show you India, right? Or if it show you at Australia, it will show you Saudi Arabia. Whatever is this is, you find it out where I am right now. I am in which part of the continent. Now, when you zoom it out, you will see states. right? When you zoom it out, you will see the districts, and when you zoom it out, zoom in, you will see the cities, and then when you zoom in, you will see the actual locations. So what you're doing with the zoom part, you are actually going to increase the level of abstraction, right? Okay, with each zoom you are getting more and more information, right? Now there are two type of abstractions. One is called the procedural abstraction, and another is called the data abstraction. So procedural abstraction, as the name suggests, that it hides the procedure, and the data abstraction, it hides the data. So we will see this with the help of one example. We'll explain it. That it says, suppose we say it open the door. If I give this command to a robotic or humanoid, a robot or a humanoid, then what it does, it will generally it has two type of abstractions. Open is a word for you, but because you were not born with this word, you do not know this word. How you learn? You learn it from your parents, or you learn it from your surroundings. Then how you actually learn? If you were sitting somewhere at the age of 2 or 1.5 or 2, somebody open this door, you don't understand. Then what he do, what he or she will should have done, he or she should have gone to the door, grab the handle, open the door, and tell, this is how we open the door. Okay, so moving from your place to the door, grabbing the handle, pushing or pulling that particular thing has 3 or 4 steps, and all these steps are hidden now with a word called open. Somebody say open the book. Okay, open the book and go to page number 64. In the schools you do this. Okay, your mind actually reads that word, right? And it creates all process within it. Within seconds you understand what the other person actually wants. Okay, this one thing which is a gift from the almighty to a human being is the abstraction. If we abstract it, this is the power of the language. The second thing is data abstraction. Now the door can be the wooden door. It can be an aluminium door. It can be a metallic door. It can be a glass door, right? So it might have different dimensions. It might have different weights. So what you do once you write a particular what you can say, you write a particular specification, you don't mention what type of door is going to be implemented. You only mention the word called door. Okay, when the system is going to implement, at that implementation time, the designer or the person who is going to implement may choose whatever things better fits in, right? So you abstracted what type of data that should be going here, right? So you abstracted two things. Open the door has both the abstraction, right? The data as well as the procedural. Now, then with the concept of abstraction, there comes a concept of refinement. The process of refinement is opposite of what you can say abstraction. It is like elaboration. So start with the statement of the function defined at the abstracted levels. Decompose the statement into functions in a stepwise fashion until the programming language statements are reached. So a relation between abstraction and refinements can be depicted with this particular diagram. It says abstraction suppresses low level details. Refinement reveals the low level details. So they are complementary concepts to each other. Okay. With refinements, you reveal out more things. With abstraction, you hide things, right? Both are complementary and both are necessary in software development. Now, there is one more thing, which is the second concept. The third is called modularity. Modularity means you should divide a particular problem into sub problems, right? It should divide into problems into sub problems, and you should. Why we want to do this? Because we want to achieve control of the system. We want to make it more manageable and in day-to-day life, but we cannot create this particular division right? It is saying that it is a divide and conquer concept, which is very powerful conquer concept. But the thing, you cannot keep on dividing it endlessly. So example is, if you want to eat a pizza or eat a chapati, what you do, you break it down, because you cannot eat at once, right? You cannot eat take one complete chapati and put it in your mouth. You cannot do that. So you break it out into small slices, right? But how many slices? The question is this, right? You cannot break it into n number of slices. A slices that should be small as your thin as your hair. You cannot do that. So it is not, it looks good also, it does not, it will not suffice you, right? The problem, and it is not manageable also. But if you break it less, just half of the chapati, then only it is not manageable. So there should be a right mix of number of modules, that it helps you to eat fast, and it should also be manageable. The same thing happens here. So this is a diagram that explains you the concept of modularity and software cost. It says that on the y-axis you have a cost or effort, and on the x-axis you have a number of modules. If you see this thing, if you see the diagram, it says actually that if you see this, it says actually that this cost goes down. This cost is the highest when the number of modules, when the number of modules is less. So let's say M1, the number of modules, you see that the cost is the highest. This is the C1, right? C1 is the cost when you have M1 module. And when you go to this Mn, the cost is less. Okay, this is the cost C2. But so I ideally you should say I should go for Mn, right, or Cn, because I have a Cn cost. But what you see, there's another curve that you can see here, right? This is the cost to integrate. So once you reach Mn, the cost is integrating is very high. This is the cost that is very high, right? If you are at M1, this cost is very low, right? This cost is very low. So at this time, what we want to say is, you should have a trade-off between the cost to integrate and the cost per module. So you choose a point where these two graphs intersect with each other, and you take plus and minus that particular value, and you call this a region of minimum cost, right? So these region of minimum cost are the number of modules that a software should have in order to ideally integrate easily, and the cost per module should be less. Okay, so this was all about modularity. We will continue this topic modularity in our next video, and we'll talk about the criteria that should be taken care when we discuss about modularity. Thank you very much, and looking forward to see you in the next video.